In this short video, we're going to talk about the marginal rate of substitution. The marginal rate of substitution is defined as the change in good y over the change in good x that leaves the consumer indifferent between the final resulting basket and what they started out with. Right? So specifically, the marginal rate of substitution is equal to the absolute value of the change in y over the change in x that leaves the consumer indifferent, where y and x are the quantities of good y and good x that they're consuming. And this is the change. Okay? It's the change in good y over change in good x keeping utility the same. Now I could write such that utility is kept the same, but that's just implied by this. Now you might ask, why do we take the absolute value? Well, if we're keeping a person at the same level of utility, then if we're giving them, let's say, more of good y, so change in good y is a positive number, say change in y is positive, then if we're going to keep them indifferent, that's not allow them to be any happier, then they must be giving up some of the other good, so change in x must be negative. If we gave them more of both, then by the more is better assumption, they would be happier and hence would not have the same level of utility. So we would not be leaving them indifferent. Okay. So change in y over change in x is negative, and we take the absolute value of it. That gives us a positive number, which is the marginal rate of substitution. And I should say that technically it's defined as the marginal rate of substitution of x for y. So there's a subscript xy is equal to this. So here it's x for y. You have the change of y in the numerator and the change in x in the denominator. Okay, so let's go back to those graphs that we were looking at in the last video, those indifference curve graphs. I'm going to plot it here. So we're going to have the amount of good y on the vertical axis, the amount of good x on the horizontal axis. And if you recall, as you move along this indifference curve, you're leaving the consumer indifferent. So if we were to go from this point to this point, then we have it tells us the change in y. It's basically the vertical difference between these points. That's a change in y. And if you look at the horizontal distance, that's a change in x. That change in y and change in x are the changes that would leave this consumer indifferent. Why? Because the two points fall in the same indifference curve, so they must be providing the same level of utility. Okay, so change in y over change in x is equal to the slope of the indifference curve. We take the absolute value, that gives us the marginal rate of substitution of x for y. So the marginal rate of substitution is equal to the absolute value of the slope of the indifference curve. That's the first relationship that I want you to remember. Next, I want to add the budget line to this graph. And recall from our previous video that the slope of the indifference curve should be equal to the slope of the budget line. And if you recall or look back to the last lecture, the slope of the budget line, so I can write slope budget line, is equal to minus the price of x over the price of good y. Okay. If we take the absolute value of that, then we've derived that since they have the same slope, take the absolute value of this slope, take the absolute value of that slope, we've derived that the marginal rate of substitution of x for y is equal to the absolute value of y, change in y over change in x, which is equal to the absolute value of the slope of the budget line, which is just the price of x over price of y. It gets rid of the minus sign there. That disappears. And so now we know that this relationship holds. There's one other relationship that I want to introduce, and then I'm going to provide some intuition for some of these relationships. So I'm going to tell you that the marginal rate of substitution of x for y, which by definition is equal to the absolute value of the change in y over change in x, leaving the consumer indifferent. That is going to be equal to the marginal utility of x over the marginal utility of y. So the marginal utility gives us the the change in utility as just x changes. So it's a rate of change in utility as the person gets more x. And the marginal utility of y is defined similarly. Okay, so here we have that marginal substitution is a change in y over change in x, leaving the consumer indifferent. And I'm telling you it's equal to the marginal utility of x over the marginal utility of y. So on the right side here, we have x in the numerator and y in the denominator. And on the left side, we have the opposite. Now, the intuition here is that if you need twice as much of good y, let's say you need 2 units of good y to be left indifferent after giving up 1 unit of good x, then good x must provide twice as much utility as good y. So the marginal utility of x must be twice as high as the marginal utility of y. Or if the change in y over change in x, leaving the person as indifferent, is 3, so the person would need to get 3 units of good y to be indifferent to giving up 1 unit of good x, then the marginal utility of x must be 3 times as high as the marginal utility of y. Okay, so that's the intuition there. And recall that that change in y over change in x, the absolute value that leaving a person indifferent, is equal to price of x over the price of y. Okay, this is just combining this relationship here with this relationship here. All right? If marginal utility of x over marginal utility of y is equal to the marginal rate of substitution, and price of x over price of y is also equal to the marginal rate of substitution, then you must get this latter relationship here. Okay. And if we rearrange that, if we just focus on this part highlighted by the orange, if we rearrange that, we could yield a relationship which is rather intuitive. So let's rearrange that. Let's divide both sides by the price of x and multiply both sides by the marginal utility of y. Okay, so that's basically taking this orange part, and it yields that we have that mu of x over the price of good x is equal to the marginal utility of y over the price of y. So let's just look at one side of this equation, the marginal utility of x over the price of x. If we divide the marginal utilities that you get from 1 unit of good x by its price, then that's giving you the marginal utility per dollar spent on good x. Right? Suppose that the price of good x was 5 and the marginal utility was 10. That suggests that for each dollar you spend on good x, it gives you 2 utiles. If I were to give you an extra dollar and you were to spend that on good x, that would give you 2 more utiles. Right, so the idea behind this equation, this last equation here, is that the utility received per dollar spent on good x should be the same as the utility received per dollar spent on good y. If that were not the case, then the consumer could reach a higher level of utility by shifting their consumption basket. Right? Suppose each dollar spent on good x gives more utility than each dollar spent on good y, then the person would want to buy less of good y and use that remaining income to buy more of good x, the remaining budget to buy more of good x. Right? So that's the intuition there. The last thing I wanted to do is to quickly go over how you calculate the marginal utility using math or using calculus. Let's assume a particular utility function. Let's assume that utility is equal to 2 times the amount of good x consumed times the amount of good y consumed. Okay? And let's assume that the initial basket has this person consuming 2 units of good x and 10 units of good y. Okay? So the question I have for you is, what is the marginal utility of good x? So you can pause the video for a second, think about how you answer that, and when you're ready to either resume or you're really stuck, you can unpause. So pause it now. Okay, so how do we do this? Well, the marginal utility is the rate in the change of utility as x changes. Or it's the slope of utility with respect to x. Not the slope of the indifference curve, the slope of utility with respect to x. How do we get that? Well, in the last class, we covered that that is equal to the partial derivative with respect to x. So to get the marginal utility, good x, that's going to be equal to the partial utility, partial derivative of utility with respect to good x, which if you look at this function, it's just equal to 2 times y. I'm taking the partial derivative with respect to good x, so we just treat y as a constant. And so the derivative is equal to this. If we want to know what the marginal utility is, if we want a numerical solution, we have to plug in the starting value of good y, which was 10. So if we plug that in, then we get that the marginal utility is equal to 20. This ends this short video. In the next short video, we'll start to actually solve for the optimal consumption basket for a consumer using calculus-based methods.